Hello, this is Miles. Can you hear me? Miles?
We are live right now, Juan. I will start folks, we'll start the webinar in another 2 minutes. People are still joining in. We'll start shortly, Juan. Folks, I'm going to start with the introduction while we wait for more people to join in. Welcome to the Implementing Automotive Cybersecurity in the Supply Chain Best Practices. You are joined today by Mr. Vignesh Sambandhan, Dr. Juan Pimentel, and myself, Chad Keimel. We're very happy to be here with you today. In fact, I have the pleasure of doing the initial slides and the presentations, and then turning it over to Omnex's experts, which is Juan and Vignesh. So with that, let's get going on this very interesting subject of automotive cybersecurity. A brief introduction to who Omnex is. Many of you attend, we do multiple webinars and you may have attended, but we always get new attendees. So let me just tell them who we are. So Omnex is a global training and implementation and also software company. We're headquartered in Ann Arbor, Michigan. We have offices globally. And of course, our forte is working with companies implementing initiatives from different industries. And, very proud to say we are the authors of many of the standards that we talk about. In fact, Dr. Juan Pimentel is one of the writers or the contributors to ISO 21434 for the United States. A quick look at Omnex offices worldwide. This is something we are very proud to do. We are supporting our customers in this, international automotive industry with customers and suppliers all over the world. We not only are in automotive, but we are also in aerospace, semiconductor, and medical devices. We separated EV, electric vehicles, and autonomous vehicles from our standard offerings. And of course, as the industry moves into EV, AV, we'll be merging the two, but we have a whole practice in this electric vehicle, autonomous vehicle. And Juan and myself and Vignesh, we have written many, many papers about how all these different standards work, how ISO 21434 works with ASPICE, how functional safety and cybersecurity interface with each other, how to do integrated new product development, which is one of my pet topics. So do write to Miles if you'd like to learn more about these other standards. A quick look at what Omnex does, including in ISO 21434 or R155 or R156. We do a gap analysis, and then we help you implement, and we also have product certifications. We are just months away from announcing our safe, secure certifications, division. A quick look at Dr. Juan Pimentel's background. you can see that he's got he's worked a lot in hardware. He's a PhD in hardware and done an extensive amount of research. He used to be a professor at Kettering, and he's been with us for a while and doing many different projects, both in functional safety and cybersecurity. Vignesh focuses both on functional safety and cybersecurity. Lately, he's been doing many of our cybersecurity projects, including many different cybersecurity ISO 21434 assessments and audits. He's also a TARA expert. All right, here we are. This is the webinar that we have promised: Implementing Automotive Cybersecurity in the Supply Chain, Best Practices. And with that, let me turn things over to Dr. Juan Pimentel. There you go, Juan.
All right, let me share my screen. You should be able to see my screen now. Can you give me a feedback? Do you see one or two screens?
We see your screen, Juan.
We see two screens.
Oh.
Now we see one screen.
Oh, all right.
Okay, now it's fine.
Yes. Yeah, okay. Good morning, everyone, and welcome to this webinar. And thanks, Chad, for the nice introduction. And as you could see, the topic for today's webinar is about best practices implementing automotive cybersecurity. At Omnex, we have worked with several clients in the last few years on implementing cybersecurity. And it has been quite challenging, I would say. And because of our working with these clients, we have learned many questions that they had, many issues, and many things that they would really love to know ahead of time implementing these standards. So for that reason, we decided to have this webinar, which are really a compendium of best practices. The assumption is that you already know a fair amount of 21434, which is the Automotive Cybersecurity Standard. And also, you're familiar with the regulations of the European regulations R155 and R156. We don't expect for you to be experts in the areas, but we do expect that you're fairly knowledgeable about these two documents, at least. So with that, let me go over the outline that we'll go over the main points that we will cover in this webinar. First of all, we'll set up the context that we're talking about, and that is the current status of the implementation of automotive cybersecurity standards and regulation. I will briefly summarize ISO 21434, which is the main standard for automotive cybersecurity, and then these regulations, particularly R155, which stands for Cybersecurity Management System. We will review the new attack vectors that are coming out because it has a bearing on our best practices, and as well as latest incidents and the current situation in the automotive cybersecurity landscape. I will talk a bit about data security because it's one of the new topics that is coming out, as well as the convergence of IT and OT cybersecurity. IT meaning information technology, and OT is operational technology. Also, one of the best practices have to do with implementing cybersecurity in the supply chain, so we will summarize that topic briefly. And then just summarize and explain our best practices in the context of what has been covered previous to that. And we will conclude with some conclusions, and also we'll show you some a listing of the courses and services that's offered by Omnex in areas related to cybersecurity. So first of all, this is only a preview of the best practices that we have compiled. I'm not going to explain in great detail because that will be forthcoming, but these are our best practices. You could see there are 8 of them. The first one is implementing standards and regulation as a team with the tier 1s and tier 2s and OEMs all together. Number 2, realizing that automotive cybersecurity is not just ISO 21434, it's much more than that, and we'll explain that particular point. Also, the need to do a comprehensive TARA, and this is particularly coming from ISO 21434, but as well as R155. We will review briefly the recent attack vectors in the industry, and then the next best practice is about the solution landscape that's available for everyone for implementing automotive cybersecurity. The next best practice is about implementing portions of the standards, meaning that as an organization, you don't have to implement all of these requirements, all of these standards. Rather, the implementation is shared between OEMs and tier ones and tier two. So that's kind of good news. Number 7 is early on in the process, you need to be defining a testing and verification environment. That's so crucial. And the last one is working with your suppliers or working in a supply chain organization, particularly this detailing a very well written CIA, which means cybersecurity interface agreements. So this is a preview of the things that we will explain, and these are our best practices for you. So in terms of the context, this figure, it's a little bit dated, but nevertheless, it showed that just before, in fact, this figure was published just before we began work on ISO 21434. So ISO 21434 is not the first standard. There have been several documents prior to that. And this is an example of that. As you can see, you have documents related to 2006 and 7, 27,000 series, 2000 series of ISO. Also standards that starts with an X, which comes from the ITU, with the International Telecommunications Union, which is a European body for standards. You have SAE standards such as 3101, 3138, and even you have one from ISO here regarding certificates, ISO 20828. So the point is that prior to the development of ISO 21434, there were many documents and standards already available. The standard 21434 is a so-called product standard. Okay. And the product obviously is components of a vehicle, all the way to including the entire vehicle. But we're really talking about components of the vehicle, which standards called an item. That's the viewpoint of this particular standard. So this one kind of shows several elements of the vehicle that could have a bearing on cybersecurity. And there are many reasons why product cybersecurity is important. In this one, we list some of those, particularly high connectivity, related technologies, particularly wireless technologies, sophisticated infotainment and HMIs, and then high level of comfort and convenience. So all of these are good in a modern vehicle. However, the bad news is that they constitute attack vectors. In other words, they constitute places where hackers can get into the system and do some damage. Again, very briefly, I'm not going to spend too much time on this, just to an overview of the main points. ISO 21434 is the main standard from ISO for cybersecurity engineering for road vehicles. The purpose, there are several of them. One of them is that to realize that cybersecurity is key for new product development. As mentioned before, new vehicles are offering additional functionalities and content that are of electrical and electronics nature. That's what -E means. That is the good news. The bad news is that they constitute means for hackers to get into the system and do some damage. The main features of this standard is that it is risk-based. In fact, they define 2 risk levels. One is called CAL and the other one is risk value. It is life cycle based. You could clearly see the concept phase, development phase, and the post-development phases. It leverages ISO 26262 in many ways. Particularly, the IDA definition is the same, and the management aspects are extremely similar. In a nutshell, 21434 provides a really great framework to enable cybersecurity management, as well as other technologies. This is a top-level depiction of the main parts of this standard. Each part actually is called a clause. So you have clause 5, 6, 7, 8, all the way through 15. Clauses 1 through 4, they don't have requirements. So only clauses 5 through 15 have requirements for implementing them. As you could see, the first two clauses, 5 and 6, are management-oriented. Management with respect to the company, 5, or with the product or project, which is 6. Number 8 is interesting because this is very specific to cybersecurity. You don't have a counterpart on clause 8 in functional safety, for instance. It's called continual cybersecurity activities. These are activities that are performed throughout the lifetime of the products. And number 7 have to do with the stuff that I mentioned, that implementing automotive cybersecurity is a supply chain an effort. So this one talks about the activities with the suppliers in order to implement the standard. The life cycle phases are in the middle section, the big boxes here, clauses 9, 10, 11, 12, 13, and 14. 9 is the concept phase, and 10 is the product development phase. As you could see, 10 and 11 does cover validation and verification, which is in clause 10, which is not shown explicitly. And clauses 12, 13, and 14 are post-development phases, which means that those are the cybersecurity activities that a designer needs to take into account after the product has been developed. Clause 15 is a companion clause that details the methods for performing the TARA, okay, the threat analysis and risk assessment, which is a very important component within 9. Okay. I mentioned that clause 8 is very interesting and important because this is new. We don't have a counterpart in functional safety. And this illustrates the activities in this clause 8. So we're talking about monitoring information in the supply chain through many stakeholders, actually. And the reason they do the monitoring because that eventually you may find out events, or you may find out what is called incidents. So it's an escalation of the criticality of that information. So simply information may be an event or maybe an incident, depending upon the criticality of it. The standard talks about that if you decide that it is an event, you have to manage properly. And also, if you decide that it is an incident, not only you have to manage properly, but you have to perform the so-called incident response, which is a very formal procedure. In addition to that, you need to perform, again, vulnerability analysis and also manage those vulnerabilities. It may require that you go back to the concept phase and perform a TARA. Initially, TARA is done in clause 9, as you could see here at the beginning. The cybersecurity monitoring, as I pointed out before, this is done throughout the life cycle of the product, meaning that way after the product is manufactured and actually it's in the user hands, you continue performing these activities. In terms of the regulation 155, which is one of the portions of WP.29, it's called. 155 stands for, or it's about a so-called cybersecurity management system, okay? And it is a regulation as opposed to a standard by the European community. But basically, any OEM that wants to sell vehicles in Europe, they have to meet this regulation, okay? So This regulation has many requirements. The bottom line is the requirements for the designer. There are also requirements for the OEM in terms of registering the vehicle and answering a bunch of questions, but I'm strictly, for this webinar, I'm talking about the technical requirements from the viewpoint of cybersecurity, okay? There are 17 group of requirements in 3 categories: OEM specific, vehicle specific, and also for backend servers and holding data, like in the cloud. So this applies to the cloud. So I may mention that at this point, R155 is a bit more general than ISO 21434, because 21434 only covers within the vehicle perimeter, whereas 155 covers even outside the vehicle perimeter. In addition to 155, we have 156, which is a companion regulation. That's one way to look at it. That includes requirements specific to address threats related to software updates. At the end of the day, an OEM is the ultimate party responsible for implementing all requirements with the help of their supplier base. Here is additional information on 155. Particularly the stuff that's pointed out in blue is very important. This standard, but this is also true for 21434, they require processes, either creation of utilization of processes to address and mitigate attacks. So again, I pointed out earlier a couple of times, at least, that it is expected that OEMs will work with the entire value chain, with their suppliers, in order to implement the totality of these regulations. Okay. So it is expected that with these regulations, the OEMs and the supply chain actually are better able to identify and respond to security risks associated with new and emerging vehicle architectures, mobility services, which is one of the new things that are coming out, and also to the connected vehicle ecosystem. So it's very future looking in terms of having these requirements apply not only to the current issues, but emerging issues that may come up in the future. The R155 particularly talks about requirements related to backend servers, related to communication channels, not only wire communications, but also wireless communications, vehicles regarding the update procedures, or regarding unintended human actions facilitating a cyber attack, or their external connectivity and connections, and also taking a look at the enormous amount of vehicle data and code. Okay, so in terms of what's going on recently, there are many new attack vectors that are coming up. And these next 3 or 4 slides talk about even to the year 2022. So this information is very recent. So we're talking about that there are new attack vectors in these categories. The first category is telematics and application servers, which is really outside the scope of 21434, but it's very important to realize that this is a big attack vector. So this is basically making use of servers and the cloud type of information that's outside the vehicle perimeter. Another one that is fairly new is keyless entry, remote keyless, which means wireless keyless. This is obviously for stealing or getting access to a physical car, and this involves wireless technology. Okay. The third group that's important is ECUs. Okay. ECUs have been around a long time, and the hackers are continue to exploit the ECUs. Not only the ECUs traditionally that have to do with the internal working of the car, but even ECUs that have to do with telematics. For instance, there is a telematics control unit, as a matter of fact, that is a target for the new attack vectors. Still another area are, in general, we have a lot of software, as you know, in the cars, and the amount of software will continue to increase. And a big aspect of the software is the so-called APIs, which is the application programmatic interface or programming interface. This constitutes a new attack vector that's being exploited today. Mobile applications are on the rise, okay, for various reasons, but they also constitute an attack vector for hackers to get access through that mobile applications to the vehicle and be able to control critical control functions. Infotainment systems have been around for a while, and this continue to be an attack vector that is important for attackers and also for defenders. So these infotainment systems, I think everybody's fairly familiar with. By this, they constitute a great place for attackers to get into the system initially. And from there, they could access the communication networks like the CAN bus or other networks, and then access to other ECUs and do a lot of damage. A new attack vector that is that just happened recently is taking advantage of the electric vehicle charging infrastructure. So as you know, electric vehicles need to be charged, and when they go to these charging stations, they get access to the grid. And through that grid, there are many ways that attackers can get into the car itself and access a lot of information or do a lot of damage. Bluetooth has been around for a long time. And the attack vector associated with Bluetooth continues to be exploited because it's happening more and more, particularly with mobile applications. And then we have the over-the-air software updates, OTA, that again constitute a great attack vector. By the way, many of these have several examples that just happened the last year or the last few years. Unfortunately, because of space considerations, we cannot give you information about that. But here we gave you one. In May 2022, hackers discovered a new attack vector in a Chinese OEM, which allowed them to conduct unapproved software upgrades to vehicles. So what are the implications of these new attack vectors? Well, there are many, as you could imagine. This is just a short list of them. First of all, as I pointed out again also, the smart mobility. Even though this produces a great deal of advantages, it also has some issues because they introduce new attack vectors. Also, the connectivity of vehicles. We're talking about vehicle to vehicle, vehicle to infrastructure, vehicle to persons. They also constitute a great place for hackers to gain into the system, to get access to the system. And then to realize that automotive cybersecurity is much more than what's inside the vehicle. It also involves IT cybersecurity. And these are some of the examples that are correlated to not only automotive cybersecurity, but IT cybersecurity. For instance, subscription services, third-party mobile apps, charging infrastructure, as I mentioned before, fleet management, mobility as a service, and even new insurance models. So at this point, we have a poll question. Here, Miles, I think we have a slightly different version of this question. Can you administer this poll question on your end and see the answers? There you go.
Poll is launched.
So there's a slightly different version of this same poll question here. Please rank to highest to lowest these particular areas where you see that the highest percentage of incidents happens. In other words, do you believe that the highest percentage of incidents is in APIs, for instance, or infotainment? So rank them in a relative order. Okay, so the answers came in. So let's see. The answers are color coded. Highest is blue, lowest is reddish. Okay. So A is about 50%. B is highest. Oops. Ranking. C almost similar to A. APIs again high. Infotainment came very low. F came kind of in the middle, just like the first one. And Bluetooth came overall equally. Okay, great. So let me go to the next slide, because next slide is the result of a recent study made by Upstream Security, which shows the percentage, the actual percentage actually, of these latest incidents. It showed that as of last year, and this was surprising, telematics and app server was 35%, remote keyless, 18%, ECUs, TCUs, gateways, 14%, APIs, 12%, infotainment, 8%. It's interesting to know that infotainment was much higher in the years prior to that. It's coming down. Mobile apps, 6%, EV charging, 4%, and Bluetooth, 3%. So this is a bit surprising, because in the past few years, Bluetooth was higher, and so was ECUs. And what is really surprising here is the EV charging is starting to pick up, and this telematics and app servers, which is basically on the cloud, are becoming much higher. And also the remote keyless entry. That's another area it's a bit surprising. I think the reason for that is that if you think about it, those are the areas where it's the easiest to perpetrate the attacks. So the landscape is definitely changing, okay? Another area of change, for instance, is the sheer amount of dollars involved in these attacks. Relatively speaking, automotive, in the years 2019 to 2023, $505 billion. As an example, banking is 347 billion and insurance is 305 billion. So automotive is surpassing that of banking and insurance. Also, there is an increase in data privacy. That's also very interesting. Okay. There is also an increase in the number of thefts and break-ins, and also the financial impact to insurance providers is becoming to be noticeable. All right. Along with this, we have another poll. Okay. So Miles, please administer this poll. Similar to the one before, but this one is to try to estimate, okay, the highest percentage of different types of incidents in these categories in terms of data privacy, service disruption, vehicle theft, fraud, and stuff like that. All right, here is the partial answer. So business disruption was very low. Data privacy was kind of in the middle. Vehicle break-ins are a little bit higher than that. The vehicle control systems, fraud was the highest. Okay. ISF, the manipulation of vehicle system, would be the lowest. Location tracking, kind of in the middle. The violations and other would be the last. That's kind of understandable. All right. So let me show you again the answers. Again, this study was conducted by the same company, Upstream Cybersecurity. And this was a bit surprising to me also. The highest percentage was in data privacy, which is pointing out that there is a new area in this whole area of automotive cybersecurity called data security that is extremely important. The next one is the service disruption, 23%. Vehicle thefts and break-ins, 22%. Controlling the vehicle, other controls, 13%. And then all the others were kind of low, below 3%. Fraud, manipulating the car systems, location tracking, policy violation, or others. So the very interesting thing here is about this data breach, data security, which is the next topic. So data security is different than cybersecurity. There are many things in common, of course. They're very similar, and yet they're distinctly different. The main thing about data security, I would say that it has to do with the second point here. It deals with personal identifiable information, the so-called PII, that includes, including the collection of this data, the processing of that data, storing that data, or transferring that data, particularly if you could do a cross-country transfer. There are many regulations, particularly GDPR in Europe, CPRA in California, and MIT in China that focus strictly on data security. And this is an upcoming thing where we see some regulations, but unfortunately, we don't have too many standards in the area of data security. So this is an area that is in our recommendation also to focus with data security. Also, we mentioned that there is a convergence between IT and OT cybersecurity, operational technology. So strictly speaking, automotive cybersecurity belongs to OT. It's an operation. It is not an information technology. However, they are intertwined. You can no longer talk about automotive cybersecurity in a silo. You have to talk about IT and OT cybersecurity. So it involves technologies and a convergence of methodologies of both IT and OT cybersecurity. I borrowed this diagram, in fact, from the defense sector, where they try to categorize the layer of defense of cybersecurity in several areas: perimeter security, network security, endpoint security, application security, and data security, as well as talking about the operational aspects and also the management aspects. So this is not directly related to the ISO standard, but you could clearly see that some areas here have a bearing on ISO 21434 and also even on the regulations, not directly, but indirectly. So I have put here a specific topics or sub-areas in each one of these categories belonging to this framework of cybersecurity, pertaining to these various layers of protection, and also pertaining to the particular techniques of cybersecurity. For instance, you could see GDPR here, data protection, you have Bluetooth protection, you have secure domains, you have firewalls, you have OBD2 protection, IDS, IPS. On the left, you have the meaning of those acronyms in case you don't remember. So the bottom line here is that when you think of automotive cybersecurity, it's no longer strictly automotive. It goes beyond automotive. In terms of the new CVEs found, this is the listing in the last few years, okay? Obviously, they're increasing, and as you know, CVE means for cybersecurity vulnerability exposures. Those are the actual vulnerabilities found by various people, okay? Also, in terms of where the vulnerabilities belong in the supply chain, OEM 75, relatively speaking, 32 pertaining to tier 1, 130 pertaining to tier 2, and then 110 pertaining to the service providers. I mentioned that automotive cybersecurity is not just ISO 21434. Here is a list of additional standards that have a bearing. These are important standards, and even this list is not comprehensive or totally inclusive. There are probably a few others that have a bearing, but you're talking about here, in addition to obviously WP.29 and 21434, you have 24089, okay, which is related to the requirements, and then you have a few other ones. And I let Vignesh speak about these standards as well as other considerations. Vignesh?
Yes, thank you, Juan. So I will take you all through a few slides, a few topics on the different standards in automotive cybersecurity. As Juan has mentioned, he has focused on important standards like ISO 21434, but there are a lot of other standards as vehicle manufacturers, as component manufacturers, you might have to focus on. So next few minutes, we will understand the significance of these standards and how this will impact your product development. Okay, so Juan has mentioned about R155 and R156. So I will broadly divide these different standards into three things. One is we have regulation, which is R155 and R156, which is driving all the standards. So countries have regulations. So in this case, UN has a working party, WP29, and they have this R155 and 156 regulation, which is coming into place into full all the vehicles from 2024 July. And this regulation is driving a lot of other standards in the industry. So we have many standards, and then we have some best practices as well. Okay. And one of the two main standards that is related to cybersecurity and software update is one is ISO 21434, which is directly related to the R155, the cybersecurity management system. So if your organization is focusing on implementing R155 requirements on cybersecurity management system, ISO 21434 is directly impacting you. So this standard gives different perspectives on how to do product development, which Juan has already covered in detail. And another important standard which has recently published is ISO 24089. 24089 has a direct impact and a direct relationship with the R156 regulation. Okay, by following this regulation, you can cover most of the aspects. By following this ISO 24089, you can cover most of the aspects of R156. So R156 and ISO 24089 talk about the software update management system. Okay, I have one slide to go in detail for that. And there are a few companion standards as well. Okay, whenever we talk about cybersecurity in automotive, we talk about vulnerabilities and how to handle those vulnerabilities. So these two standards, next two standards, ISO 30111 and ISO 29147, talks about the vulnerabilities and how do you handle that. So ISO 30111 talks about vulnerability handling. So once you have identified a vulnerability for your particular product, how do you handle those vulnerabilities? And we have ISO 29147, which talks about the vulnerability disclosure procedures. Okay, and this is impacting vendors And when you receive vulnerabilities, or also when you disclose vulnerabilities, how do you handle that? There are a few guidelines as well. I have a quick slide to cover that. And then you all must be familiar with Automotive Spice. Automotive Spice has a plugin for cybersecurity, okay, which is also impacting all the manufacturers, which if you're into Automotive Spice, you might have to take a look at this. Omnex, we are working on developing a lot of these standards. We are working with customers and implementing these standards as well. There are a few companion standards where, depending on the product you are developing, might impact you. For example, you have SAE J3101, which talks about hardware-assisted functions and the best practices and the requirements for that. You have SAE J3138, which talks about security for any external test equipments. And finally, ISO 15118, specifically the part 2 of it, which talks about when you have a EV, electric vehicle, and the electric vehicle supply equipment information exchange, so which is the charging infrastructure, what kind of security you need to look at. Okay. We can go to the next slide. So let us quickly look at the standards which are not discussed in the previous slides. One is ISO 24089, which is called the software update engineering. So this particular standard was officially published this year in February, okay? And as I have said, this standard directly has a relationship with UNR 156. So the standard covers mainly how the software update will be handled by organizations. So in this case, it can be your over-there software update, it can be your physical software update. So the standard gives you requirements. How do you implement policies and procedures at your organization level and at your project level? And there are a few requirements for your infrastructure-related security handling for software updates. You have for vehicle and vehicle systems level. And there are 2 topics on software update package. How do you package information and verify and validate the software update package? And also, how do you do software update campaign requirements? Okay, how do you prepare that, execute that, and complete that? This is one of the important standard manufacturers are working on complying. Okay. Next slide, please. And ISO 29147 and 30111 are very closely related to each other. Okay. 29147 is mainly for vendors and reporters who report vulnerabilities. So when vendors or reporters report vulnerabilities to manufacturers, there should be a clear communication path. There should be a process established to report these vulnerabilities. So 29147 primarily talks about that. And 30111 is mainly the internal vendor process. So once you receive vulnerabilities from your reporters, how do you handle those vulnerabilities? So this could include your triaging of vulnerabilities, your investigation and remediation of the vulnerabilities. Okay, so these 2 standards always go hand in hand. Next slide, please. All right. And then we have a lot of best practices in the industry. So NHTSA has cybersecurity best practices for new vehicles. I think this was recently updated last year. And EU has ENISA, which is, they talk about good practices for security of smart cars. We have supply chain cybersecurity best practices as well. And Auto ISAC has a lot of best practices like incident response practice, how you should handle that, etc. So as manufacturers, you might also have to look at these best practices because a lot of these best practices have good level of information. They talk about how do you do a risk management activity, how to follow a secure design approach, and they also talk about threat analysis, incident response, etc. Okay. In addition, these standards are not complete. There are more standards coming for automotive cybersecurity, specifically for activities like performing an audit. So you have a standard called ISO 5112, which talks about how to audit cybersecurity systems. And when it comes to project level evaluation, there is an upcoming standard called ISO 5888, which talks about cybersecurity evaluation. And we also have a few other standards coming for validation of cybersecurity activities, which are not currently explained in detail in the current standards. So this one is called ISO 8477, which talks about cybersecurity verification and validation. And there are a few standards for maturity model and cybersecurity assurance level as well. So cybersecurity standards are continuously evolving. New standards are coming up. So as manufacturers, you might have to involve in implementing these standards and ensuring security of your work products. Okay. So I will hand it over to Juan. Juan, please take over.
Okay, yeah, thank you, Vignesh. So
Thank you.
moving forward, again, as it was pointed out, there are many requirements, and the responsibility for implementing the cybersecurity requirements is shared between an OEM and the supply chain, particularly tier 1 organizations and tier 2 requirements. So you could think of requirements then as belonging to OEM requirements, tier 1 requirements, and tier 2 requirements, which are color-coded in this diagram. Some of these are shared, as you could see, but the sharing depends upon the level at which the organizations work. So it's very important to have this effort. So at the end of the day, which is what I mentioned earlier also, a single organization is not expected to implement all of the requirements of all of the standards, all of the regulations. It is a shared effort, so which is the good news. However, managing that implementation is not trivial, and we'll talk about that later on. Again, this is another summary as an example of what standards are applicable to some organizations. Some of them are generic. For instance, 21434 is an umbrella type of standard. You could imagine that they're important for all of them, but not in the same fashion. OEMs look at 21434 differently than tier 1s, differently than tier 2s. However, there are some standards, for instance, J3101, which is strictly applicable for tier 2, not for tier 1s and OEMs. Again, this is another diagram of what we call the landscape, pretty much what it has been talking about before, putting into a graphics format. And I added here, in addition to 27,000 NIST 800 series that have to do a lot with IT cybersecurity. And this goes along with the fact that I mentioned that automotive cybersecurity is no longer strictly automotive. It is automotive plus IT cybersecurity. And this is the reason why you bring other areas or other standards, even from the grid, from the cloud, and from IT. All right, going back to the best practices that we compiled for you, hopefully now they will be better understood, and now it's time to explain a bit more about each one of these best practices. So number one, it says, implement the standards and regulation as a team effort. So this was pointed out a few times. You have OEM organizations, tier 1 organizations, tier 2 organizations. The best practice is that you need to see this as a team effort, to work as a team rather than adversarial type of work. So it's extremely important that you view it as a team effort. Number two, automotive cybersecurity is much more than just ISO 21434. This was explained several ways. Okay. First of all, we need IT cybersecurity, which is broad, and this involves even the smart mobility sector. It also involves regulations in addition to standards. And there's just a few examples. We're expecting to have more regulations coming up in the future, particularly for data security. Automotive cybersecurity, based on 21434, follows a very specific framework and also a process, which begins with an IDAM definition. You define the assets, Then you identify threats, and from the threats, you identify your goals. From the goals, you develop design requirements, and then you move on, of course, from the design requirements to implement and bring in cybersecurity controls to be able to meet your goals. So this design process is very specific to automotive. However, IT follows a different process altogether. They do not based on item definition. Rather, they use established frameworks. So it's very important that you consider the framework. So there is a framework for the defense sector, for manufacturing, for even the telecommunications industry. They have a different framework. But these frameworks, again, share some similar methodologies and methods. Okay, but at the end of the day, we see two main frameworks. One is totally automotive, and the other one is IT-related framework. So you need to consider those two frameworks and keep it clear that you're talking about different frameworks, because you need to implement standards or requirements belonging to these two different type of frameworks. Also, we showed you that the nature of the recent attack vectors is changing. And actually, this will show up. If you do your item definition very well with 21434, that will show up with the recent attack vectors, because the item definition keeps track of the latest vulnerabilities in your product. Okay. Particularly, you need to pay attention to the so-called continual vulnerability assessment, which is part of Clause 8 of ISO 21434. Best practice number 5 is that you need to be extremely aware that the solutions landscape for automotive cybersecurity follows this continual cybersecurity that we talked about. Therefore, you have to perform event management and incident response. And this could be in scope or out of scope. The reason for the question mark here is that it depends on your product. In general, the answer is yes, but a particular product may not have all of these items in scope. So this is why it's very important that this item definition or this TARA is done very well and ahead of time, because it will guide you through the remaining of the process. Also, you need to leverage the supply chain, which is related to a previous one, but it is extremely important. We have seen, working with several customers, that some projects did not go well. And in analyzing the reason for that is because the supply chain cooperation was not well done from the very beginning. Number 7, the testing, verification, validation, just like in functional safety for cybersecurity, is extremely important. And you need to define this early in the process. The problem that we have seen is that companies or projects have defined this late in the process, and this has caused a lot of problems. Okay, particularly because the various players did not know what they were responsible for doing. Not only that, but there aren't too many, I guess, companies or even people who are extreme experts in automotive cybersecurity. We have much more experience and many more experts in IT cybersecurity, but not so much in automotive cybersecurity. So waiting for this to do at the end, especially with people with not enough experience in automotive, then this is a very difficult thing to do. So we recommend that you do this early in the process. You get in experts in automotive to help you out. And the last one is the CIAs. Going back to the supply chain again. As you know, CIA means Cybersecurity Interface Agreement. In fact, there is an entire clause number 7 of ISO 21434 deals with CIAs, which means that you need to do a comprehensive document detailing everything that needs to be shared between the various players in a CIA. Also, the last thing I want to mention is that Omnex has a product called EWQ IMS. And this product has several modules. And the most significant modules that I like to talk about today is functional safety and cybersecurity. However, as you could see here, it has modules for ASPICE and IATF as well. So this is the portion that deals with the cybersecurity. As you could see here, we have implemented these modules, okay? In addition to, it works together with IATF, with ASPICE, and with functional safety. And here on the right side, you have elements of this particular implementation dealing with the plan, requirements, and the configuration. These are additional information about this. We have implemented 43 work products. The standard talks about 45, but we found out that 2 work products are not being used by our customers lately. We may expand that in the future. There are also modules for cybersecurity audit, assessment, the cybersecurity plan, the flow down, requirements flow down, TARA, and the cybersecurity case. So if you're interested in this particular product, then I encourage you to go to the Omnex website and look at EWQIMS. So in conclusions, the industry is moving forward along with the implementation of 21434, R55, and I56 implementations. The industry is getting a lot of experience as well as a lot of challenges through these implementations. There are new attack vectors and vulnerabilities that are gradually increasing. The automotive cybersecurity is no longer a silo, but rather it needs to be implemented together with information technology, which really opens a lot of doors, a lot of possibilities for additional work. Automotive cybersecurity is the responsibility of the entire supply chain. The OEM would be the ultimate responsible party. However, the OEM is expected to work with Tier 1s and Tier 2 organizations. Now, working with partners have become imperative, and it's extremely important that you identify what should be in a CIA, the Cybersecurity Interface Agreement, and develop a good CIA from the very beginning so that you could work smoothly with all your suppliers. And the last one is that new standards are emerging. The latest standards are in the area of data security, mobility applications, and grid cybersecurity. At the end, you have additional information on upcoming training from Omnex related to cybersecurity and related areas. So you may take note of some of this, or you could come to the website and also view some of this. We have a whole curriculum for cybersecurity, as you could see here. We have training on ASPICE or SPICE, and also in functional safety. And this continues. Also, related to functional safety, you have core tools like DFMEAs, fault tree analysis, and hazard analysis. We also have a few courses on the Agile and SOTIV. And SOTIV would be pertaining to the automated vehicles. And the standard is 21448. There is also training available on the latest editions of FMEA, particularly the so-called AIAG VDA version of it. Again, this is the software I mentioned earlier. And as you could see here, it has a complete set of modules. These are the 7 levers, the main areas that Omnex is concentrating. As you could see, IATF, functional safety, SPICE, supply chain practices, SOTIV, cybersecurity, and Agile APQP. And Omnex services has several categories, and we do work in all of these areas. So if you need help in assessment, audits, implementation of standards, even help with engineering, gap analysis, then you need to go to the Omnex website and get additional information. With that, I'd like to close the webinar and we're open for some questions, if there is any. Miles, were you able to see some questions posted?
Yeah, there is a question posted in the Q&A.
Could you read the question for me, please?
Sure. It says, do the automotive OEMs require compliance or third-party certification to ISO 21434? If so, how is that communicated?
Yeah, no, the answer is no. ISO 21434 does not require that. There is the so-called informal certification done through companies like Omnex. In other words, the entire supply chain organizations, they require certification among one another. In other words, an OEM will require a tier one organization say, you need to implement 21434, and they have to do that. Otherwise, they will not get the business. So it's done at that level, but it is not a formal process.
Well, I think that's what they're asking. Do the OEMs require that? And how do they communicate? I think that's through their CSRs. Is that correct?
Yeah, there are several ways that they communicate that. One way is through just a regular, when they select suppliers, they will require that implementation. Okay.
Okay, and we have another question that I can answer. It says, will the slides be available for viewing? And yes, they will. Just give us some time to get the recording up and it will be available on our website.
Oh, okay.
That's it.
All right. Well, with that, then, I'd like to thank everybody for your participation, and I hope you have benefit from this webinar, and good luck on your cybersecurity endeavors. Thank you, and goodbye.
Thank you.